Hi, my name is Susan Wu. I'm the Senior Product Marketing Manager in Network Services, Network Security Business Unit. I actually handle service mesh, and prior to this I was at CNABU for Kubernetes, and then many eons ago I worked at Docker and OpenStack and CloudStack. So actually I'm here to tell you a little bit about implementing persistence in Kubernetes. It's not for the whole Kubernetes talk because I only have 10 minutes. So there are a lot of sessions about Kubernetes that you can go to, a lot of Tanzu sessions. So this is only about implementing persistent storage. Very quickly about the applications. Architectures are changing. I started my life in Java, so it's monolithic. The whole team, I think 200 of us, all use the same IDE. We only check in code once a week, and then we have peer review, and it was pretty much impossible to kind of dictate the type of architecture that you want to do. And it's a little bit unflexible. We used to use the waterfall method, so we would code and then we would find something at the very, very end. And we've seen even showstopper bugs. But now, fast forward 10 years, about 2000-ish time frame, many companies started adopting microservices, smaller teams. They get to choose their stack and also their favorite backends, all of it connected with REST API. And so this is really changing. People can revise their application, they control that stack, they can iterate on their own intervals. That's kind of how it's happening. But in reality, not every application in the enterprise is in microservice pattern. VMware, we still have quite a bit in Java. We still have some LAMP. But we started moving a lot of our customer-facing services like myvmware.com to microservices. And so with that, moving to microservices is prompting the use of containers and moving to Kubernetes. We've been meeting a lot of customers, and generally they've been faced with similar problems before they adopted Kubernetes. They've had failed applications in production. They need a lot of lead time before they could deploy. And what was really common now that I'm in networking is they're looking for a common set of APIs to provision infrastructure, network infrastructure, and other infrastructure as part of even like a CI/CD pipeline. So just for the product that I work on, NSX, it actually exposes the REST APIs, and you might be familiar, that actually you can actually provision like a distributed router or a VPN, all using the REST API. So there's some sessions here where some VMware engineers coded Python Django, including the NSX APIs, and then show how to provision, auto provision the VPNs. And they also show doing that same cycle onto, say, VMware Cloud and also on-premise. And then they also use the same kind of pipeline technology to seamlessly connect their security policies on-premise as well as on the public cloud. So that's what's happening. So on Kubernetes, why do you need persistent volume? Of course, to run stateful application. If everything's stateless, you wouldn't even need to do that. And so Kubernetes itself actually has ways for you to write to a file system. So you can write to a container file system, but the problem with that is the container, when that dies, that file system's gone, the data's gone. And of course you could write to a volume, and then it's tied to the life of the pod. When the pod dies and restart it, you lose that data. So Kubernetes started out including something called persistent volume, which actually survives the life of a pod, a container, and even the node. It survives the life of a cluster itself. So how do you do, oh shoot. Okay, so stateless application, everything's configured separately. You use something called deployment, which creates the replica sets. And then the replica sets, let's say you chose 3, Kubernetes would check the state. If the state has fewer than 3, it's meaning it has less than the desired state, Kubernetes would create that replica set for you. But the challenge is that this is a kind of written to a remote storage. And if you have multiple containers and you try to deploy persistence, then all the containers are talking to the same store, which is not ideal. With stateful applications, you have something called stateful sets. I think in the past this was called pet sets, in Kubernetes. So this is information that's stored locally by the application, and you have read-write access. It's commonly known as pets. How this works is, let me switch to the next slide. How this works is actually it creates pods with its own names, and then a user would request the storage using something called persistent volume claim. And then what happens is, then the persistent volume is actually tied to a backend storage. In the case of vSphere, it's tied to vSAN data store. So it's actually backed by a persistent volume. And then the users would request it using the persistent volume claim. And then the same situation happens is if there's a, if you have a desire for a certain number of pods and the state shows that it's less than the desired, then Kubernetes would actually replace that pod for the pod that has failed or it's been evicted. And then actually it would actually associate that new pod with the appropriate resources that you've defined. And then it's how it works is when you the storage administrator first backs up that Kubernetes with the type of backend storage. In the case of vSphere, it's actually block storage. And then the storage administrator or the container administrator would define the storage classes and then expose that to the users and to vSphere. And that is my last slide. If you have any questions about persistent storage. We also have another session that's given by Gopala. He's a PM for vSAN storage about container native, and I think it's tomorrow morning. You can look for that. Sure. I'm sorry? So in the case of vSphere, it's actually backed up with the VMDK and then written to the vSAN data store as a file system. And then of course backed up. So you back up this is a container running on a VM. So the information is backed up to the VMDK, and that VMDK is actually mapped to the vSAN data store. And then of course you have the real disk. Thank you for the question. Yeah. Any other questions? Oh, okay.
What goes into deciding between Kubernetes persistent volumes and external storage?
Oh, so mainly it's the applications. So if it's a stateless application, it would be sort of like a, you would use a model called deployment. So there were like two methods. One's called deployment, one is called Stateful Set. And so if you use the deployment model, it would back up to the remote, and it would access it through the remote protocol.
So it's stateless versus stateful from a Kubernetes standpoint?
Yeah, from an application standpoint.
The data is still there in your case, right? Because if you're running to external,
Yeah,
it's still there.
correct. Absolutely, you're right. Yeah, so the state is persistent.